Throughout this video, we will share some basic information about the TyrFil flushless pump, as well as safety procedures, required tools and materials, machine setup, proper tire filling techniques, machine shutdown and cleanup, and general machine maintenance. Ensure you have the necessary equipment required for the TyrFil flat-proofing pumping system at your location, including a flat-proofing log for record keeping, a cleaning solvent such as 99% isopropyl alcohol, hypodermic needles, tools, rags for cleanup, and safety items such as safety glasses and chemically resistant gloves, a fire extinguisher, tire safety cage, first aid kit with eye wash station, and safety data sheets. Due to the combustible materials you will be handling, there should be no smoking, grinding, or open flames in the workspace with signs posted, and spectators should be carefully monitored. Refer to the OSHA guidelines for additional safety information. Compliance is unique at each location and should be in accordance with all local, state, and federal regulations. Flat-proofing material should be stored indoors in a controllable environment of 72 degrees Fahrenheit or warmer. Never store flat-proofing materials outside. Prior to processing, the materials must be at least 72 degrees Fahrenheit to ensure proper mix and curing times. During cold weather processing, allow for extra curing time. 24 to 48 hours is recommended. When moving the equipment or changing totes, care must be given to keep the hoses on the correct side. TyrFil's IsoSide product is sensitive to moisture. It requires the use of a desiccant to remove any moisture from the air as it enters the tote. To install the desiccant cartridge, simply peel off the tabs on both sides of the canister. On the canister, there is an arrow which indicates the direction of airflow. The arrow must be pointed towards the tote. Remove the white 2-inch center bong on the IsoSide tote. Grease the threads of the desiccant holder and screw the assembly into the center opening. Place the filter in the desiccant holder and tighten the hose clamp. Make sure the inspection window is visible from the front of the tote. Change the cartridge when the inspection window turns pink. When hooking up new totes, inspect the ball valve for damage that may have occurred during shipping. Remove the shipping cap and foil seal and apply a thin coat of grease to the tote connector. Screw the tote connector onto the ball valve, hand tighten only. Apply grease to the tote connector and inside of the cam lock, then connect the cam lock to the tote connector, locking the cam lock in place by pulling back on the handles and inserting the pins. Repeat this procedure for the other tote. The inside of the tire must be cleaned and dried. Water, sealants, glycol, calcium chloride, soaps, bead lubricants, or even dirt must be removed from the tire. If the tire is rinsed, the inside of the tire must be dried prior to flat-proofing. Wheels should be inspected for cracks, metal fatigue, and corrosion. Bent, cracked, or rusted wheels are a safety hazard and should not be used. New tires should be pre-stretched by inflating to operating pressure for 24 hours at 72 degrees Fahrenheit before filling. Pre-stretching the tire ensures that it will be filled to its capacity and will minimize long-term carcass growth during service. Used tires do not need to be pre-stretched and will require more flat-proofing product than a new tire. The best results and value are obtained when flat-proofing new tires. For tube-type tires, always use a new properly sized tube. Wheels that require the use of flaps must be filled with a flap in place. If the flap is removed, the tube has a greater chance of rupturing during the filling process. The TyrFil flat-proofing material is injected into the tire through the valve stem. At the same time, air is removed or vented through an opening or needle at the 12 o'clock position. Liquid flat-proofing material fills the inside cavity of the tire. When the tire is full, the needle is removed and the hole is plugged with a nail or screw. The tire is then pressurized for the correct application. The valve stem is then sealed and the tire is laid flat to cure. After 24 to 48 hours, a solid elastomer is formed. The tire is now permanently flat-proofed and can be put into service. Flat-proof tires are pressurized not with air but with flat-proofing material. It is important that before you begin flat-proofing, you know the operating pressure of the tire. If you are uncertain about the pressure, refer to the manufacturer's data book or the yearbook by the Tire and Rim Association. Never pressurize the tire above the maximum pressure as indicated on the sidewall, rim, or wheel rating. There is a fundamental difference between pressurizing a tire with air and pressurizing a tire with TyrFil's flat-proofing materials. Gases are compressible, liquids are not. Pressurizing a tire with air is a gradual process with pressure building slowly from the initial introduction of air. With TyrFil's flat-proofing process, the tire is vented during the filling procedure so there is little pressure buildup until the tire is totally filled. Then the pressure builds rapidly while pumping a very small additional amount of material. TyrFil has a flat-proofing weight chart in addition to an online flat-proofing estimator to help you approximate weight and cost for flat-proofing tires. This information will be useful as it will help you determine if you have enough material to do the job, and you can monitor the progress of each tire as it is filled. A resettable counter displays the cycle count. Multiply the displayed count by 0.81 to convert to pounds. In addition, you were provided with an operator's manual. Please keep your manual handy so you'll have access to more detailed information as well as troubleshooting. Remove the manifold head, mixing components, and fluid gun from the solvent container and wipe off any excess solvent with a dry rag. Visually check to ensure all items are free of residue. Starting with the mixing tube, insert the white mixing elements. Position the mixing tube with the tapered end down and insert the flat end of the first element into the mixing tube, stopping 1 inch from the top. Next, insert the second element into the notch of the first element and push down. Repeat the procedure for the third and fourth element. Do not use broken elements. Always keep an extra set of elements on hand. Dry the solvent from the ends of the mixing tube and whip hose and apply Teflon tape to the threads. Attach the mixing tube to the coupler on the manifold head and tighten. Attach the sample valve to the other end of the mixing tube. Attach the whip hose to the other end of the sample valve and tighten all connections. Complete the assembly by attaching the fluid gun to the end of the whip hose. Attach the air hose to the air motor connector. Make certain the manifold hand valve is closed when turning the pump on. Adjust the air regulator on the pump to 80 psi. Open the white 2-inch bong to vent the cat side tote. Open the ball valves on the ISO and cat side totes. Turn the air supply to the air motor pump on. Open the manifold handle over a waste bucket to pump fluid and prime the system. Close the manifold handle. Apply a coat of grease to the quick connects on the manifold handle. Holding the manifold handle in one hand, pull up on the female quick connects. Attach the manifold end to the handle and press down until it locks in place. Attach the smart gauge to the gauge air stem. Make sure the drain valve and gauge valves are closed. Open the manifold handle. Run 2 cycles of product through the system into the waste bucket to flush the remnants of the cleaning solution. Close the manifold handle. Since the material is injected into the tire through the valve stem, it is to your advantage to use the largest straight valve stem available. Angled stems are more restrictive and will take longer to fill. The larger inside diameter of the air-water valve stems can reduce filling times by 50 to 60%. Position the tire vertically in the cage with the valve stem at the 6 o'clock position. Remove the valve core or air-water valve from the tire that has been inflated for pre-stretching and load the core into the fluid gun. Attach the gun connector to the stem. Attach the gun to the gun connector. Prepare a quality control sample by pumping flat-proofing material into a small Ziploc bag and label with the time and date. Lay the sample with the tires that have been flat-proofed. This will serve as a visual indicator of the material during the curing cycle. After the tires are cured, the samples should be retained for future reference should any problems arise while the flat-proof tires are in service. Most small tires will completely deflate before you can attach the fluid gun to the valve stem. Here is a time-saving tip. When filling tires using an air-water valve, you can connect the fluid gun to the stem and use the core extractor in the fluid gun to remove the air-water valve. This step works only with the air-water valve. Regular cores should be removed by hand and inserted into the proper core holder. Reset the flow counter to 0. Identify the operating pressure of the tire you are filling. In most cases, it will be the recommended air pressure for that application. Open the hand valve on the flushless pump manifold and begin filling the tire. Frequently turn off the hand valve and open the pressure valve on the accessory stem to check the internal pressure. Continue pumping until the tire has enough pressure to keep the bead seated or tube inflated. To check the level of the material in the tire, tap the casing lightly with a hammer. The unfilled portion will sound louder. Drill a hole at the 12 o'clock position in a tread groove and insert an air bleed device, such as a hypodermic needle. For steel-belted tires and thick casings greater than 12 ply, you will need to drill a 1/8-inch hole through the tire to assist needle insertion. Use of TyrFil's needle inserter will make this much easier for you, and you will avoid damaging the needle. The needle only needs to puncture the tire deep enough to vent the trapped air. Stop inserting the needle once you hear air escaping from the tire. Turn the manifold hand valve back on and continue filling the tire. To keep the pressure in the tire from dropping too quickly, place your finger or thumb over the needle to stop the air from escaping. If the pressure drops too low, a tubeless tire may lose its bead seat, and a tube in the tube tire may sag, possibly tearing the tube with the needle. Continue pumping. The tire is full when material flows from the needle. Close the manifold hand valve. Remove the needle and plug the vent hole with a nail or screw. Open the pressure valve on the manifold and check the internal pressure of the tire. Turn on the manifold hand valve and pressurize the tire to its operating recommended pressure. Remember that fluids are not compressible and pressure will build quickly. If the tire gets overpressurized during the filling process, close the manifold hand valve and open the drain valve. Pressure inside of the tire will force the flat-proofing material through the drain valve, reducing the tire's internal pressure. Close the drain valve to check the pressure. Once the correct pressure has been reached, close the drain valve. After the tire has been pressurized to the recommended operating pressure, leave the pressure valve open. Press the plunger on the fluid gun. Seat the valve by rotating the plunger clockwise. Pull back on the plunger. If the valve core is seated, the pressure on the gauge will drop to 0. If you have more tires to fill, reset the stroke counter and repeat the procedure for other tires. For tube-type tires that require drilling, it is best to pre-drill these tires before mounting. If pre-drilling is not an option, apply a vacuum to the tube with a tube deflator before flat-proofing. The tube deflator will collapse the tube inside of the tire, giving you a few inches of room to safely drill a pilot hole through the tread. Use a short drill bit when performing this procedure. Remember that you are only drilling through the tire. You do not want to damage the tube. After you have drilled the tire, the tube must be reinflated before flat-proofing. The stem is needed to reseat and refill the tube with air. Another option is to place a patch on the tube in the area where the tire will be vented for reinforcement. The filled tire must now be laid flat to cure. Tires can be placed on pallets to make handling easier and help maintain the temperature, especially during winter. Write the weight and the PSI on the tire. Record the data in your flat-proofing logbook. This logbook is used to record processing data for the customer wanting more information. Do not overpressurize tires. In addition to the possibility of a violent rupture, overpressurizing will cause crowning and possible splitting of the carcass upon impacting an object such as a curb or pothole. Once the material has cured, there is no way to correct this problem. Underpressurizing the tire could cause excessive flexing of the casing and material, which may lead to overheating and eventual tire failure. Warmth speeds the cure. The minimum processing and curing temperature is 72 degrees. If 72 degrees cannot be maintained, longer curing times of 48 hours or more will be needed before the tires can be returned to service. Begin by checking the position of the cylinders. The cylinders must be in the lowest position so that the cylinder rods are completely submerged. Slightly open the manifold hand valve over the waste container and close it when the cylinders are at the bottom. Turn off the main air supply to the air motor. Open the manifold hand valve once again over the waste container to release the pressure in the cylinders. When the pressure on the cylinder gauges go to 0, close the hand valve. Hang the manifold body on the flushless pump and turn off the air supply. Remove the manifold head from the manifold hand valve. Remove the fluid gun from the whip hose. Remove the fluid gun plunger from the fluid gun. Remove the whip hose and sample valve from the mixing tube. Disconnect the pressure gauge and the mixing tube from the manifold head, leaving the coupler on the head. With the ejection rod, remove the mixing elements from the tube. Clean the fluid gun in solvent. Clean the fluid gun plunger in solvent. Lay the whip hose in solvent and clean the sample drain valve with the brush. Make sure the sample drain valve is open. Clean the mixing tube with the brush. Place the mixing tube in the solvent. Clean the mixing elements in the solvent and store them in a safe place to avoid breakage. Open the manifold head pressure gauge valve and clean the manifold head connectors. Store the manifold head in the solvent. Clean the stem connector and store in the solvent. The mixing components and whip hose must remain in the solvent during storage. The solvent level must be high enough to completely cover all items. Keep all solvents covered when not in use. Proper maintenance is the key to long equipment life, reliability, and efficiency. Flat proofing does not have to be a messy procedure as long as your work areas are kept clean and the pump is in good working order. On initial setup or after cylinder replacement, the wet cup should be filled 1/4 of the way with throat seal lubricant. This oil provides critical lubrication to the piston rods and helps seal the Teflon packings. With normal use, the TSL oil and the wet cup will change color as the flat-proofing material penetrates the seals. This is normal. The ISO side material will begin to harden once it has accumulated in the cup. When the material begins to gel, scoop the material out with your finger. After the cup has been cleaned, refill with clean TSL oil. TSL oil will evaporate and should be checked weekly even if the pump is not used. The Teflon seals under the cup require periodic adjustment. Use the spanner wrench supplied with the pump to tighten the cup seals. Over-tightening will damage the seals. To ensure that the material does not solidify in the hoses and cylinders between uses, the pump needs to be operated once a week. Ensure that the manifold hand valve is turned off. Turn on the main air supply to the air motor. Open the supply valves on the totes. Open the manifold hand valve over the waste container and pump 10 to 15 strokes of material. Shut down the pump in the same manner as before. Congratulations, you have successfully shut down and cleaned the TyrFil flushless system. These important steps will allow you to be prepared and ready for the next time you will fill a tire.